Welcome everyone to our first Dcubed webinar here today. Good evening, good afternoon, and good morning around the world. We'll be talking today about the smoothest test campaign you've ever run, and we're super excited to have all of you here with us. Just as a heads up, we'll be recording this session and then it will be available afterwards on our social media. We'll be talking after a quick introduction today about some of your key testing challenges that you're probably very familiar with. We'll give you a quick product demo of some of our release mechanisms. And then we'll hear from two of our valuable customers on their experiences of working with us and with our products. And then Guillaume from our engineering team will tell you a little bit about application cases and lessons learned he has seen throughout the years. And last but not least, you'll have the chance for some questions and answers. So make sure to use the Q&A function here on the tool. And just as a heads up, we'll be rewarding the person who asks the best question with a free Dcubed giveaway at the end. So as you have those questions come up throughout the webinar, feel free to submit them and we'll get to them towards the end. Here are your hosts and speakers for today. So I'm Marcus, Commercial Director here at Dcubed, and I'm joined by Valentina on Sales and BD side and Guillaume on the Customer Solutions Engineering team. And then, as I mentioned, our two customers that have dialed in today. We have Chris from Hawkeye360 in the US, and then Jordan from Gama in France. So that's who you'll be hearing from within the next hour. But before I get more into what I've prepared, here's your chance to participate. So my question to you is, what are your biggest test campaign challenges that you have probably come across way too often while working on some space hardware in the past? So feel free to either go to slido.com and punch in the code 7019900, or use the QR code at the top to access the poll, and then let me know what you've been struggling with mostly. Seems like there's a lot of challenges out there. Hardware limitations and availability, along with test facility schedules and pre-booked appointments, seems to be one of the biggest ones. Okay, cool. Well, unfortunately, this is the truth that we and a lot of our partners and customers have been facing. So maybe I'll tell you a little bit about what we've been doing to help you avoid this and address this next time you need to go to do a test campaign. But before I do so, I thought maybe it's a good time to do a quick demo of our products, just in case you don't remember or you haven't seen how they work live. So I'm going to stop sharing. I hope you can still see me and hear me. And here it is. This is our nano pin pooler. It's a shape memory alloy-based release mechanism made out of 7075 aluminum with hard anodization. It also is fully redundant, so it has two independent trigger lines and it has telemetry. So with this little actuator, you can sort of launch anything and lock anything in shear, ideally. Once it releases, the spring-loaded mechanism that you have applied this to will open. And to show you how easy it is, all you need is some sort of a power supply. I just use my AA's to hook that up with one of the lines, and there it releases. After you've done your trigger, obviously you want to do tons and tons of testing. So a quick and easy and cheap reset is crucial. So what we supply you with is the tool you need is a mechanical reset tool. All you do is push that in through the back, and there you go. You're back in flight configuration, just like that. If you don't have a shear load application, but let's say you have a axial preload case that you want to constrain, you better use the release nut. It's the same form factor, same internal shape memory mechanism, but instead of the pin going in, this has the nut come out. Again, redundant trigger line, so I just power up one of them, and what you'll see is, oh, get that right, the release nut coming out. So this sort of deploys axially, and this reset is even simpler. All you need is to kind of click that back in here, and just like that, you're back in flight configuration. Now with that, let me go back to my slides. I hope you can see them again, and address some of those challenges that you have also voiced and that we've seen over and over again, unfortunately. First one is testing complexity. Okay, where with maybe other solutions, you need to touch your final configuration after you've tested and kind of reload, rearm, replace an actuator, while with the shape memory solutions we provide, you can truly test as you fly and fly as you test. And this very easy and quick sort of resetting mechanism lets you do tons and tons of testing without any extra cost and any lost time. And all the tools, so for the pin puller, for example, the reset tooling is, of course, free of charge included with the product. And with that, you can do hundreds of tests without having to replace or refurbish or break your final tested configuration. That, of course, saves you time, and also the fact that our hardware is rapidly available as commercial off-the-shelf products. That saves you time and makes sure that you will meet your testing schedule, your pre-booked testing slot at a test house externally. So we offer them through a very easy and fast ordering process. There is no export control on our parts, and we have a local presence. Our headquarters is in Munich, Germany, and we have a US presence in Colorado. So with that, we can serve pretty much all of our customers, ranging from APAC to Europe to the US and North America. We offer an option where you can expedite order in case you need a quick replacement. We ship these things pretty much, next flight out if we had to. And we're following an e-commerce approach where you can purchase by credit card or PayPal if you choose to do so. And finally, all of this also lets you save quite a bit of cost, especially because we include some free engineering consulting. So GM and the customer solutions engineers, they will come and help you, whether it's through a design review, it's on-site test support, it's some troubleshooting or what have you. So we're really here to be your partner to make you successful, because only then we can be successful ourselves. And as I said, the other savings in cost is because those triggers, those resets, and all these deployment cycles are free. No need to budget any additional cost in there for after you've done a deployment test. We need to rearm or replace any of those actuators. Okay, so I hope this gives you a good overview of what we're talking about and how we've been helping a lot of our customers globally. And with that, I would like to pass on the word to Valentina.
Thanks, Marcus. As you now saw how the product works, in case you weren't familiar and got some more information, in case you have any questions, again, kindly reminder to put those in the Q&A section. We do have, besides the very cute Lego figures that you saw in some pictures, hoodies and socks that you'll see some sneak peek at the end of the webinar. So in case you would like to win one, put down your questions and will select the best one. But now time to share the virtual stage with the two incredible engineers, Christopher from Hawkeye360 and Jordan from Gama Space. So Chris, Jordan, thanks again for being with us this afternoon and this morning for you, Chris. I'll start off with the first question. So thinking about your your research for an older release mechanism or release actuators partner, first of all, what was the project that you were selecting them for, and then what were the three most important factors for the decision? Chris, if you want, you can kick off. Mentioning Lego figures is not a value answer, just so you know.
Thanks. How did you know it'd be my first response? Hi, everyone. I'm Chris. I work at Hawkeye360, and thanks again for inviting me to speak today. So for, I guess, the top three most important factors, it was really like ease of integration and resetting the actuators. I should mention also before all of this that we use the Dcubed release nut. We've also looked at the Smart Pack, which is a similar kind of actuating mechanism, and also the pin puller. We use the release nut on our solar panels. So we stow the panels with the nut when it's fully inserted into the Dcubed unit. And then we just provide the constant current actuation, which allows us to deploy our panels and then very, very easily restow. So the ease of integration and resetting the actuator was a very important factor for us. This has been great because we've been able to test the release nut in a lab configuration literally hundreds of times, because we're always going through our sort of power on launch vehicle separation sequence. Repeatability of testing is also super important because, like I said, we've been able to test multiple times in the lab and easily reset and restow and get ready for the next configuration. And cost and lead time has also been very favorable. We've been able to get these products very quickly. And we've even had some issues come up during our testing, and Dcubed has been great to get us stuff in a very, very rapid turnaround time. So I really appreciate that.
Thanks, Chris. Jordan, would you like to go ahead?
Yes. Hello, everybody. I'm Jordan. I work at Gama. And before I start, just at Gama, we build drag sail and solar sail. So we build deployment mechanism. So HDRM in general are like central to our designs. And so basically, when we designed our product, we thought about two things. We said, okay, we want the product to deploy when we want it to deploy, but we also don't want it to deploy early, because otherwise, if you deploy, for example, a drag sail, so to deorbit a spacecraft earlier than expected, then you end the mission. So it would be a really bad situation for us. And so we were really, really looking into something reliable that we can test a lot. And actually, we went at the beginning of the design. We were baselining another HDRM that was using an igniter. So basically, every time you need to reset the HDRM, you need to disassemble everything, change a part of it that you need to buy every time that you want to test it. So it was a pain basically to test it, because every test was really expensive, took a lot of time, and so to make our deployment mechanism really reliable, it was really complicated. Also, we dealt with a lot of problems of lead time. So the lead time was really long. We had a pretty bad relationship with our last supplier, basically. So it's really funny that what you mentioned in the first part of the webinar, because it's basically answering all our problems. Because when we found out Dcubed, I think we find you during a fair or something, and 1 week after we had the Dcubed release nut. We are using the release nuts in our facilities, and we were able to test it a lot of times. So it was pretty easy for us, and a lot of pain released from the engineering team. So I would say that the most important factor for us was the cost first. And when I say cost, it's not only the cost of the HGM itself, but the cost of actuation. Because then when you need to test it hundreds of times, like you said, Chris, but for us also, it's a really, really important part. Then you need to count the money that you will spend on the tests. And so you have the resetting itself, but also the cost of the operation itself. If it takes 1 day to dismantle all your system and to reassemble it, then your test will be way expensive than just resetting it back, and then you can test it in 10 minutes and test it hundreds of times in a day. So I would say that's the most important one from far. And then the second one would be the iteration speed for us, because we have an approach that is really, let's say, an agile approach. So when we design something, we want to test it really quickly into the design phase. And so we do, like, let's say, baby steps at every steps of design we test. And so the iteration speed, the speed at which we will be able to run an iteration, go to tests, is really important for us. And we measure, like, it's an important metric in our company. So I would say that also the iteration speeds is really important for us. And last but not least, of course, all the design consideration, volume, mass, power, loads, etc. That's still important, but I still think that the two first points I said are more important for us, actually, when we select an HGM.
Amazing. Next time you guys do the webinar for us, okay? You're promoting better than us. But yes. No, thanks so much for these. So you already touched upon the topic already, Jordan. So in case then there's something to add, feel free to go ahead. But Chris, when thinking of, I mean, Hawkeye360 is of course a very big company. So I don't know if Dcubed, I would wish for, but I don't know. I don't know if Dcubed is the only HDRM provider. So in general, let's say if you have to think of Dcubed and other providers, what has been for you guys, besides again the resetability that you mentioned in your previous reply, something that you would describe as exceptional and something you wouldn't go back from?
The Dcubed swag is pretty nice. I will say that. Sorry, just kidding. I think really, honestly, the most important thing is just the ease of integration. And Jordan had also mentioned that, and the ability to like stow, deploy, reset many times, and being able to do it in a repeatable way. And the release nut, pin puller, smart pack, like these are all pretty small, compact designs. They work very reliably. We've tested them in Vibe and TVAC, had zero problems with our deployment mechanisms. And so that has been great. And then I also think it's been very easy to work with the Dcubed team and get support if we ever run into any issues or questions or need more documentation or to order more parts. You guys are very quick on getting me a proposal for that, so thank you.
All right, thanks. Now, as there's also one of our, well, more of our engineers, but one customer solutions engineers working directly with the release actuators. They're great, but they are obviously like everything can always be improved. So to both of you, and in this case, Jordan, if you want, you may go ahead. So if you think about your ideal testing scenario, and you could make one wish, I could also give you two about our products and services. What will be that you would improve or that you would like to see in our products? And Guillaume can then work hard on make it happen.
Well, that's not that easy to answer, actually. We are pretty happy with the actuator. So we tried, I mentioned that we are using the release nut right now, but we also tried the pin puller. Both of them for us are great. We just have the release nut because it's easier to integrate into the design. I would say that in an ideal world, we if I have to make a wish, I would say that having something that works at higher temperatures would be something that would help us a lot just for reliability testing in general. So we never had a practical case when we reach the temperature limits. But I know that we have we need to make some adjustments in the thermals of the design of our product to make sure that we are not going to pass the temperature limits. But that's really like if I have to make a wish. Yes, I would
Take
say.
note, Guillaume. Okay, Chris, on your side.
So we're also using the release nut, the smart pack and the pin puller. I believe both have kind of like a sensing line to help you know if it's still deployed. The release nut doesn't have that, but the release nut is much easier to incorporate in our design because the resetting mechanism is really just like pushing the thing externally in place, whereas the other ones are from internal. So like if, in our case, this is built into our spacecraft panel, the spacecraft is closed up, I can't insert a tool to reset. So with the release nut, it would be nice to have a sensing line that shows that the system has been reset. We had to separately incorporate a plunger switch that gets compressed, and then that gives us our sensing circuitry. It's not a big deal, but it could be cool if this was incorporated into the design. And then in terms of testing, we had in our TVAC test campaign, we did something in our software where we were providing a constant current to the release nut for maybe like 60 seconds without realizing it. So we were heating that resistive alloy for kind of a long time. And we kind of went into like maybe a potential overheating concern where we didn't use the system in the right way. So I guess it could be cool if there was a built-in safety mechanism for overheating. So you kind of just provide the current and then like it like limits it in some way. But then again, the release nut is also like a very simple design and easy to integrate. And so that also makes things a lot easier. So if I had to wish, like we ran into this TVAC problem and that would have been cool to avoid, but then we had great customer support from Guillaume to help resolve the issue. And then having a sensing line for the release nut would also be really cool.
Amazing. If I will try to help you with an additional wish. So if you had to decide, let's say thinking also on both of your future projects, right? Either future satellites or future drug sales. If Dcubed had to develop a new product or to do a new actuator, would you go for a larger, a faster, or a cheaper actuator?
I would say cheaper, I think. I would say cheaper. We always...
This is accounting speaking.
Yeah, exactly. But as I said, one of the main metric we have is cost in general. So yeah, cheaper will be always like, I mean, I'm pretty happy with the size of the system, of the iteration speed, of the resetting speed. So I would say the price, the cost.
Fair.
Yeah, I would tend to agree with Jordan. I think if the costs were cheaper, that's more advantageous. But again, I don't see like a huge problem either way. Like we just wouldn't want to increase the system or have to redesign around it. So happy to keep getting the same ones so we don't have to do more engineering in that sense.
All right, perfect. One additional question is which I will give everyone also a bonus on top of questions for everyone. We'll start with Jordan and Chris. If you had to describe Dcubed with one word, what would that be? So also for the overall audience, feel free to drop a word in the chat. We may even select the best word.
I think I would say efficient.
Nice.
I would say reactive.
All right. Then thank you guys. Guillaume, I saw you took notes, so I'm very happy about that. I'm happy that after this webinar you have some homework to do. Guys, thanks again for joining us. Of course, happy to have you in the audience and address more questions if you have later on. But now I will actually give the floor to Guillaume, our customer success engineers, who will guide you through some of the application examples and lessons learned. Chris has sort of anticipated some of the issues that sometimes customers have, but now we go a bit more into detail. Guillaume, floor to you.
Thanks a lot, Valentina. So yeah, I was taking notes, and we are actually developing an actuator. I'm not sure if I can say anything about this development that we are doing, but some of those things that we were mentioning, they will be incorporated. Not all of them, because for instance, this feature of cutting automatically the power once it has been deployed, I think that this will require a lot from our side, unless we introduce some external electronics. But definitely all the other suggestions, we are trying to incorporate them. Even the one of the extended temperature range is just that one, it's a tough one. At the end of the day, the material that we are using, I'm not sure if all the attendees to the seminar or to the webinar, they are familiar. We are using nitinol, and the properties of this material, they have a given limit. So we'll give it a try. We know for certain that other applications and other companies, they did manage to get to temperatures of about 100 degrees. We'll try to get over there as well. But anyway, this section was supposed to be more like sharing of lessons learned and things that we've seen working together with some customers. And one of the most interesting things, as you were mentioning, is how easy it is to reset those actuators. And when we are thinking about resetting the actuators, you've seen, Marcus, how easy it was and so on in comparison to a burn wire or even some other HDRM solutions where the customers or the payloads are requested to send back the HDRM into the supplier so that the supplier can perform the refurbishment. When this is not the case, it's not only that it's saving time during testing, it's also opening a new approach for doing other stuff like assembly procedures. And we have a customer that we were discussing with the customer during a vibration test campaign, and they explained us how it was their process for preparing the payload. And it was a singular payload. It was a deployable that was going out of the satellite using two linear guides, and it had 4 cap cones for adjusting the preload and also for taking the launch loads. But it was more interesting. It was how they were adjusting the preload on each one of the cap cones and how were they making sure that everything was aligned. So they were folding the deployable, they were locking the deployable with our mechanism, with none of the cap cones making contact. They were adjusting manually one cap cone, just one, both in the location and in the preload. They were measuring, and after that, they were deploying the entire thing. They were folding it back, adjusting the second one, and so on and so forth. So actually, just for the adjustment of the payload, they had to do 4 different deployment tests. And that's something kind of unique, at least to my understanding, because most of the times, these kind of alignments, if you need to do 4 deployment tests just for setting the payload, with other solutions, it can be a nightmare. And on the other hand, with our actuators, this was something that was every single deployment, like after the deployment, it was taking less than 5 minutes just to have it again back in good configuration for adjusting the second cap cone. So it was something quite remarkable, and I was really impressed because for us, we've always been discussing how easy it is to do some testing with our actuators, but we never thought that our actuators could enable different assembly procedures for given payloads. On the other hand, not all the experiences have been so good, and especially when it comes to the kind of testing that can become destructive testing. So for instance, with vibration testing, that's something that has not been a unique case. It has happened quite often. And it's something really common, especially with the new space approach. There's a lot of companies that they are relying on fast iteration cycles, meaning that sometimes the design phase, it's rather quick and they are going as soon as possible to the shaker or any kind of vibration or testing facility that they have booked to verify actually that everything is working as it's supposed. In some cases, the vibration testing, it's a classic. Pretty much everyone who has been in a vibration test campaign will know that you are over there with the ear protections, just trying to listen as much as possible. And once you start hearing some uncommon noises, some rattling, it's like, oh, that's not good. And later on, after the test, if you see some particles or some dust, definitely there was something going wrong over there. And most of the times, what we have noticed in our experience is that when doing these kind of quick iteration cycles for getting into the testing as soon as possible, sometimes the payloads are designed in such a way that they can rattle a bit. And if this rattling is happening on the mechanisms, it can be critical for the mission. And for instance, we have this picture that, Marcus, please, would you mind? So this is one of our nanopin pullers that we inspected after a vibration testing on a customer site. And you can notice on that red circle that we have a change on the image. And this basically it's aluminum that was welded into the stainless steel. And you can imagine how much energy do you need to put into the system for welding aluminum into stainless steel. And this happened during vibrations because the pin puller and the unit that was holding was shocking against each other. And the amount of energy that it does require to do that, it can be brutal if this is holding an optical payload or solar cells. Therefore, design phases, even if people want to be super quick nowadays, design phases, they have to be done properly. Everything has to be understood. And those kind of phenomena, such as rattling elements and so on, have to be avoided just to make sure that you are not destroying the HDRM, but most importantly, you are not destroying the payload. In other scenarios that are also related to vibration testing, but not only necessarily vibration testing, it can be also shock testing. What we've seen is that they can be kind of not easy to predict, especially because it's really easy to predict which is the preload that you're applying on a release nut, like the one on the picture, but it's not that easy to predict which is the dynamic environment that those loads are going to be generating on the mechanism. And this highly depends on many factors. So we will not have enough time, even if we spend like an entire week just discussing about those kind of factors. But I would like to highlight a couple of elements that are kind of super important. One is the amplification factors, and the other one is the resonance frequency of the different elements. And this can be super critical because sometimes if the understanding of those dynamic loads is not proper and you underestimate them a lot, there's a chance that the dynamic load might be higher in magnitude rather than the preload that it's applied. And in those scenarios, the payloads themselves, they will start gapping, and this is going to be generating some shock events. And those shock events, depending on the design itself, the materials employed, the magnitude, or the difference between the preload and the dynamic loading, this can generate a massive amount of energy. So it's something really to keep in mind. And when doing a design, just make sure that amplification factors and resonance frequencies, they are fully understood as much as possible, and that the preload analysis or the needed preload for a given setup to be held together, it's really well understood. And safety factors over here are kings. The bigger the safety factor, the better, because if you apply a bigger preload than needed, it's all right, nothing wrong will happen. But the other way around, there is where actually the damages may start happening, especially as mentioned before, if there's any fragile elements such as solar cells, optical elements, etc., etc. And the last remark is something that we are also seeing a lot, especially with companies that want to iterate super fast. is that even if they are iterating super fast, most of the times they are assuming that things are not going to be wrong. And this has happened actually quite a few times with debug campaigns. And I'm pretty sure that a lot of people here attending this webinar, they will feel identified with that. Like, there's a debug campaign, nothing has happened during the entire week. It's coming the weekend and the campaign is scheduled for 2 more weeks. And it's like, well, why should we keep recording the data, the housekeeping data from the satellite during the weekend? Because there's not going to be anyone over there, but we are not expecting anything to happen. So let's just go spend the time or relaxing time during the weekend, and next Monday we'll see and we keep moving. But that's a tricky thing, because sometimes if there's anything going wrong, not necessarily because of the satellite or the payload, maybe there's a nitrogen leak on the debug, and then this is modifying the temperature profiles. And if you don't have data to verify how the satellite has been behaving during this time, the housekeeping data, there's a chance that if there's a failure, you will never understand why it has failed. And same goes for vibration. We have also seen some companies that, for saving some time, especially because the availability of the test houses is rather limited, and we understand that once anyone gets like the booking for a test house, you want to use and make profit of every single minute that you have on that given test house. So for that reason, we've seen companies avoiding doing resonance search between the excitation runs. But sometimes, if there's a mechanical damage on the payload, they are not noticing. They start running all the tests, and then once they are done with the testing, they just realize that, oh, well, there was a damage, but was it design excitation? Was it random? Was quasi-static? So those kind of questions, they can only be answered if there's data. So even if it's feeling like a waste, it's better to have the data collected, not needing to use or not having a need for that data at all, rather than the other way around. If there's a problem and you don't have the data, then troubleshooting means basically starting again from the get-go the entire test campaign, and sometimes even going backwards even more on the design stage. So really, even if it's feeling like a waste, record as much data as possible, because that's ultimately what it's going to save you in case of a problem. And well, those were the few things that we wanted to share with you. And make sure that next time that you're going into a test campaign, just have in mind those considerations, especially if it's a project that has really tight deadlines, because normally on those kind of quick projects with super tight deadlines, it's where most of those things are happening. So have it in mind, pay attention to those kind of details, and don't let any failure stop your mission.
And you took this out of your encyclopedia of things, right? Yeah, you have a full book at home.
Yeah, indeed. We have many experiences coming also from customers. A lot of experiences also because most of our people in our company has worked in the field, in the space domain for years, many years, even before coming to Dcubed, and we have already gathered quite a long background. And even in Dcubed, sometimes we are also rushing and we need to learn on do things better, because we know the basics. It's just that sometimes we know that game, but yeah,
we like
there's
to feel
always
like
room for
customers.
improvement. Yeah.
Perfect. Thanks so much, Guillem. Time for Q&A questions. Again, if anyone from the audience would like to ask anything to Guillem, to us, happy to reply now. Just as general information, these are some of the visuals that our hoodies, t-shirts, or even socks come with. So feel free to, if you may, or if you would like to win one, feel free to drop in a question. While we wait for any potential question, I have one for you, Guillem. So I've asked before to Chris and Jordan for their wishes. at the same time, you thanks to the several interactions that you had with the customers, for sure you also gathered things that we would like or we should improve in our actuators. So what will be, let's say, name up to 3 things that that either we are directly improving, but comes again from feedback from customers, or that you wish would be applied, so you can work to yourself?
All right, it's a good question. So the easy answer is we are developing a new actuator right now that it's in the oven. Actually, we are going to get the prototypes hopefully in a couple of weeks. And that given actuator, it's a release NAT, and the loading and the ratios of this given actuator are going to be significantly higher. So it's meant for satellites or for deployable structures that will undergo severe, really severe conditions. And I'm not sure if I'm able to share the preload target, but there's more than a factor 3 from what we have currently on our portfolio. And another thing, it's on the wires that we are using. So I think that this is a common issue with most of HDRM suppliers in the industry. And the problem is that the insulation that we are using is PTFE. Here in Europe, we have this ban of PTFE starting in 2027, unless something changes. And well, that's a tough one because PTFE is super convenient because of the outgassing properties of this plastic. But also it has some drawbacks, and is that it's not bonding properly with anything. So on our designs, we have the wires, and we are using the core of the wire for making the mechanical bonding with the mechanism. But the insulation itself, it's surrounded with some epoxy, but the epoxy is not bonding with the PTFE. Almost anything it's bonding with PTFE, so it would be nicer if we had an alternative to the PTFE that was bonding better with the epoxy, and at the same time was meeting the outgassing requirements that we are having from, we are taking the ones from ECSS standards. So that will be super nice. We are speaking with some cable providers to see whether if they have something. So far, they always told us that they have no alternative to the PTFE. But still, we are working on that, and we need to find some solutions for that, as well as any other one in the market out there. But yeah, that will be my wish.
All right, thank you. So we got one question that I would revert back to Chris and Jordan, as they were the ones that mentioned that. So William said, hopping back a bit, but when you say cost is the main metric to improve, what is the risk that customer would be willing to be okay with? So, if let's say you mentioned, both of you guys mentioned that the product as is great. What would be, I don't know, for example, Chris, you also mentioned on the release NAT that you would like feedback line is, I don't know, redundancy, different type of material, or what is that you would then accept as more risky in exchange of a cheaper product?
Maybe I can give a quick answer. My point of view on that is that when you have something that is cheap and that you can test a lot, you will make it reliable because you will test it in a lot of different configuration, and that will be always better than having something really expensive that is really like that you spend a lot of time to maybe to design, that you select the best materials or whatever, but that you can't that you can't test that easily because you will always have surprise, and so you will never make, or you will make it will be harder to make it very reliable at the end. So the approach that we have is, in general, not even for GHDRM, but also for I don't know, cut part for electronics, is Of course, you still have to consider the space environment, that you have to select something that is compatible with space environment. But as long as you have the minimum requirements, then something that is testable easily, that you can get easily with a large number, and that you can reliability testing, like doing some statistic on it, let's say, then you will have something reliable at the end, way more reliable than something that is not necessarily that would be more expensive, maybe.
Chris, you have also a point.
I mean, I am happy with the product as is, and I do like having the redundant circuitry, well, the redundant line anyway, in order to be able to provide the actuation. And so I think that's good. To Jordan's point, like the release nut in our case is something that we've tested over and over and over again in the lab. Most satellites anyway just have like zeros and ones that flip, and the release nut actually makes like our solar wings deploy, so it looks cool. And so it's been nice to have the circuitry kind of included. And so I don't really see what more we could do to make this necessarily better in terms of like reducing components. We could have like, sorry, we could have just the primary line instead of the secondary line, but I'm not sure what that would do to like the overall size of your hardware, if it makes it smaller or cheaper or easier to produce.
Okay, I guess commercial team will think about something then. Then we got another question from Adrian, who has, how does Dcubed protect your products against SE events? Ian, you want to go ahead for that?
Yes, sure. So our devices are purely mechanical devices. There's no electronic or no digital electronics on them, and they are based basically on heat. So the SMA, which is what triggers the mechanism of our products, it's an alloy that once it gets a transition temperature, it shrinks in length. And we are using this phenomena to actually unlock all the mechanisms that we are supplying to our customers. Therefore, even if there's a single event effect, unless the units or the units that are the electronics controlling the mechanism are affected, unless that's the case, our actuators will always work. They are not being affected by that. So it's a really good question. But as I said, we are just providing purely mechanical components, and as far as there's some current flowing through them, or as far as they are getting to the transition temperature, they will release.
Thanks. And on your other question, Adrian, about the fact if a release nut has ever hit somebody in the face, not on my knowledge, luckily, I hope I'm not going to be the first one doing that, particularly at conferences, but that's also a good question.
I have to say that it has happened.
Exactly. I'm sure in production or in engineering, they may do that.
Yeah. So it has happened. Thanks God, we have this policy that whenever working with actuators, everyone in the company has to wear the safety goggles. And yeah, it was a good call to have the safety goggles always when manipulating the actuators.
So Marcus, I would actually like to call you into the case when we think about pricing, as it's a topic that came several times. So besides cost reduction, let's say, that seems like is needed as everything, as always. How do you see the HDRM needs evolving, and what are the challenges that you see associated with that from your perspective as the commercial director?
Yeah, no, thank you. Thank you for the question. Maybe a quick comment on pricing towards Jordan and Chris and everybody else here wondering. It's pretty easy, right? Price is a function of quantity and lead time. So if you order enough parts with enough lead time, we can make you a stellar deal. We, in fact, have already quite a few Constellation customers that buy them in the hundreds and thousands. So, hit us up at sales at Dcubedspace.com if you're interested in a framework agreement, but our production is definitely set up to accommodate that. And in terms of, where are we headed? Where do we see the future? we definitely see the industry grow up, right? We see everybody who started out as a small CubeSat company now doing microsats and small sats. So along this trend, you will see our actuators grow up in terms of performance, in terms of preload, and as Guillaume mentioned, in terms of capabilities. So we'll still be sticking to shape memory alloy-based mechanisms, so we won't be doing any burn wires or fuse wires soon, but trying to scale that up into the tens of kilonewtons of preload. Hopefully, you'll be able to see a little bit of that at SmallSat in Utah this summer. If you happen to be in Salt Lake, swing by our booth, or later this year in Bremen at Space Tech Expo. We'll be showing off some of our bigger actuators that are in development right now.
Perfect. Sounds good. There's actually, so one last question that Adar put in the chat. Adar, I know that newspace system is always at SmallSat. Guillaume will also be there, so come by the booth if you're going to be in Salt Lake. I'm sure Guillaume can tell you more than one fun story. In the end, products work fine, but the fun, it's the fun part to have happening during test campaigns. Perfect. With that, I guess I'll give the floor back to Marcus actually for the wrap up.
Yes, perfect. Thanks, Valentina. Thanks, Guillaume. Also, thank you for sticking with us this hour. We have come to an end now here. Thank you to Jordan and Chris for dialing in and sharing some of your insights. To everyone else online, if you have questions, if you have interest and want to book a call, reach out at sales@dcubed-space.com, or you'll be also able to see this webinar hopefully tomorrow or so on our YouTube. And as we mentioned, we'll be at various conferences coming up this summer, this fall, and then in Bremen as probably the last one for the year. As always, reach out to us if you have new ideas or other requests for topics to be covered in a follow-on webinar. We're here to help you. We're your partner, and we love to hear from you with various ideas, whether it's positive or constructive. We're happy to hear it. So again, thanks everyone for dialing in. Have a good rest of your night, rest of your afternoon, rest of your day, and we'll talk to you guys soon. Thank you. Bye-bye.
We'll reach out to the winner later. Bye,
yes,
guys.
Of course. Thank you. Bye.